Hey guys, this is Kirti Vasan. Now I'm going to explain the concept of A-star search algorithm. This is a very easy and interesting concept. Now I'll explain you with an example.
A-star search algorithm. This is a very easy and interesting concept. Now we'll look deep into it. This algorithm was invented by Peter Hart, Niels Nielsen, Bertram Raphael in the year of 1968. A-star achieves better performance by using heuristics to guide its search. Basically, it's an algorithm which helps us to reach the goal state from the initial state. This is the formula for A-star search algorithm. F of n is equals to g of n plus h of n. G of n is the cost of the cheapest path from the initial state to the node n, and h of n is the cost of the cheapest path from node n to a goal state. H of n is the heuristic values of the each nodes. This is a state space graph given, and the nodes are represented in different alphabets. Now the heuristic values is given, and the g of n's are also given. Now what the heuristic value represents is the distance or cost of S from G, the goal state, is 11.5. And for A and D are as follows. S is the initial state and initial node, and G is the goal state. The 11.5 marked here is the heuristic value of S, which means the distance between S and G. And same for every other nodes. These nodes like A, B, C, D are the intermediate nodes. And these are the GFNs. The distance between S and A is 3. S and D is 4. The same as the distance between A and B is 4. These are the GFNs. Now we are going to calculate or find the path which is very optimal to reach G from S. From the node S, we can either move to node A or node D. With the formula f of n is equals to g of n plus h of n, we are calculating this cost. So to move from S to A, we are adding the g of n, which is 3, and the heuristic value of A, which is 10.1. Gives the cost as 13.1. And the same as from S to D, we are calculating 4 plus the heuristic value of D, which is 9.2. And this gives the cost as 13.2. When we compare both the cost, 13.1 is the minimal. So we are furtherly moving on to the other nodes from the node A. From node A, we can either move to node D or node B. We should neglect the node S because that's where we are already from. So we are adding the 3 and 4 plus the heuristic value of B, which is 5.8. This gives the cost as 12.8. And to move from A to D, add 3 plus 5 is the heuristic value of D, which is 9.2. And this gives the cost as 17.2. When we compare all these heuristic values, all these costs, 12.8 seems minimal. So the further movement should be from B to the next other nodes. From node B, we can either move from node E or to node C. So we are calculating all the G of S and also the heuristic value of C, which is 3.4. We are getting 14.4 as cost. And then for E, we are adding all the G of S and the heuristic value of E, which is 7.1. And that gives the cost as 19.1. So when you compare all these costs, D is the minimal one. So our path should be from S to D and then for the further nodes. From D, we have two other options. That is, we can either move to A or we can move to E. So if we move to A, we should add the G of S, which are 4, 5, plus the heuristic value of A, which is 10.1. That gives the value as 19.1. And for E, we should add 4 plus 2 plus the heuristic value of C, that is 7.1. And it gives 13.1. If we compare all these costs, 13.1, which is E, is the minimal one. From E, we can either move to B or F. As said earlier, we should neglect the node D because that's where we are already from. So from E, we are moving from B for the first. So if we add the G of n and the H of n, 4 plus 2 plus 5 plus 5.8, which is the heuristic value of B, we are getting 16.8. And if we move from E to F, we are getting the cost as 13.5. So 13.5 is the minimal compared to B and F. So we are moving from F to G and we have reached the goal state. That's how A-star algorithm works. Hope you understood the concept well. Thank you.